Hello everyone. I am Siddhivinayak Patil from CSI Division, roll number 43, and my presentation is about Spring Boot. Let's start. Part 1 Introduction. What is Spring Boot? Spring Boot is an open source Java based framework built on the Spring ecosystem that simplifies the development of standalone production ready application. For example, Java based, build on Spring Boot, rapid development, and production ready. These are the all features of Spring Boot on the screen. Let's move on further. Here we have why Spring Boot. As the question arises, why we use Spring Boot? Here are the major challenges that are being faced in the Java-based web development. Here you can see too much configuration we have to do, as well as the dependency management plus the server setup as well as the development time is very high in compared to Spring Boot and the other traditional Java-based web development. Here we move on to the existing Java-based web development. Here you can see the Java web application follows a basic architecture which follows from the client, then to the server, and we access the database. And then we get the response from the database, then again to the server, and then to the client. Here is a basic art flow, or you can say the diagram of the particular Java web development feature. Next, we have one of the example. For example, you can see the student ERP system. Here you can see the different type of user. For example, a student, a faculty member can be a user. And for example, the database, it holds the records of every student detail, every faculty detail information about that. Here you can see the user, the web application, which is the Spring Boot, and the database, that is MySQL. And which happens to have features like add student, view students, update student, and the deletion, the basically crude operations which are been performed in this. Moving on forward we have a scenario of before Spring Boot. What would happen now we have Spring Boot, what would be happening before it? We have like traditional Spring development. Here you can see there is an option of create project, config, add dependencies, and then configure the web layer. Then we have to run it. And in the Spring Boot we have to create the project, then choose the dependencies, then we have to write the code and then run. So basically, as you can see in Spring Boot, we have to like there is less configuration as well as faster development. Here you can see. Moving on to problems with the traditional Spring. Here you can see the traditional Spring requires more of the configuration and setup, which makes the development complex and time consuming. Spring Boot simplifies this with auto configuration and embedded servers. Okay. Moving on to next, the birth of Spring Boot. Spring Boot was created to simplify traditional Spring development by reducing the configuration and boilerplate code. It was released back in 2014 by the Spring team at Pivotal. Here you can see the 2004 Spring framework was designed, and then after at 2014 the Spring Boot 1.0 was released. Here you can see the configuration settings as mentioned in the slide. Moving on to further, we have a comparison of Spring versus the Spring Boot technology. Spring, there is more configuration, and Spring Boot there are less less configuration and faster development. Here you can see the features are been laid off and you can read it by yourself. All the dependencies or all the server and the running procedure is been mentioned in this particular slide. You can refer it. Moving on further, we have key features. What are the key features of Spring Boot? Here is auto configuration. Then we have starter, the dependencies, then embedded servers, then Spring ecosystem, and production features and externalized configuration. Here you can see the auto configuration option is been there. Starter dependencies, which enables the user to start with the original like the dependencies. Then we have the embedded server like Tomcat, Jetty, and Undertow. These are the all key features of Spring Boot. Moving on further, we have key features of Spring Boot. Let's recall all of them again. Like first is the auto configuration, then we have the starters, then embedded server, then Spring ecosystem, and then actuators. What is the use of it? Auto configuration, less setup. Starters, easy development. Embedded server, easy running. Spring ecosystem, which has more features. Actuators for the monitoring of this project. Now we have the part two, which is the core concepts like how the Spring Boot revolves and how it basically works. Here we have Spring Boot architecture. First of all, let's understand how the Spring Boot architecture basically works. We have client, the Spring Boot whole application, then the database. Moving on further, the key components of Spring Boot. Spring Boot has basically one, which is Spring MVC, then two, auto configuration, and three, starter dependencies, which is easily for the management system. Then we have the embedded server, the Spring Data, and then the actuators. What is auto configuration? First of all, let's understand the auto configuration. First is the developer, then we add the dependencies, then the Spring Boot is auto configuration part is done. And what actually happens, then automatic setup and application ready that we use in our projects. For example, the traditional Spring and Spring Boot. In traditional Spring, the developer enters lots of manual configuration and more setup and time. But in Spring Boot, we have have the auto configuration setup, and it runs very easily with less time consumption. And let's see how it works. It detects the dependencies, it applies the configuration by itself, and reduce very much of the manual setup. Moving on further, starter dependencies. Now, what are starter dependencies? In simple words, add one starter instead of managing the multiple individually. Like the setup is been done, like we don't have to start from the scratch. We have a faster startup, and and with it it starts all the dependencies by itself, and we have the less configuration as mentioned in the slide. Moving on further, we have the embedded server. Now, what is an embedded server? An embedded server is a packed with the application in it. For example, what are the benefits of it? Is it is easy to run, it requires less setup, and it is easy for deployment. For example, here you can see the example of an embedded server is Tomcat or Jetty. What is application? What is application properties? A configuration file which is used to customize a Java code in the Spring Boot application. What we can configure? The server settings, the database setting, the application settings, all we can do from a single property file, that is application.properties. Moving on forward, we have Spring Boot project structure. Now, this is an example of a basic Spring Boot project structure, how it should look like. It contains the Java source code, it has the resources, it has the XML file, it has the test file in the sources. Here you can see the basic structure of a Spring Boot project has been mentioned. Moving on forward, Maven in Spring Boot. Now, what is Maven? Maven is a build and the dependency tool which is used in Spring Boot. Key functions: the dependency management, the build automation, and the pom.xml, which defines the project, the dependencies, plugins, and build configurations. Moving on, the dependency injection. Now, what is the dependency injection? It is a design where the Spring provides the required objects to a class instead of the class creating them itself. For example, what are the benefits? Easy testing and reusability. For example, with dependency injection, we have the Spring Boot, the container, the student repository, and loosely coupled is the data, and which requires less time consumption, and it is easy for the deployment. Inversion of the control. What is IOC? Inversion of control means that a control of creating and managing objects is given to the Spring container instead of the application code. What are the benefits? Less coupling and easy testing. Moving on, part 3, how it works. Let's see how it works. Now imagine this. You open a shopping website and click view product. What happens? You and the product. Like what actually happens? Let's see. It is the request and response cycle. It how it works. It goes from the client to the Spring Boot application, which is the server, and then to the database. Here you can see all the steps are been mentioned, like the layers, for example, the controller layer, the service layer, and the repository layer, all are mentioned here. Moving on forward, but who handles these requests? Imagine hundreds of requests arriving at a web application at the same time. Who receives them? Who decides what to do? Let's see. Spring MVC architecture. Here you can see the client, the controller, the model, the view, and the servlet has been given. These are the entities for this particular structure. Here you can see the client requests, then gets invoked by a particular model from the controller, which controls in it that who requests and who processes it and returns to the response. Here you can see view has been forwarded to the dispatch servlet, and from that a response has been generated and provided to the client. For example, now imagine someone has to receive the request, right? Like, for example, a restaurant. analogy. For example, a customer enters a restaurant and he don't directly go to the kitchen to have a particular order. He orders it from the waiter. And in Spring Boot, this order is been taken by the controller here. For example, let's move on forward. The controller setup. Its key innovations are the REST controller, the request mapping, the path variable, the request body, and the returns the response. For example, here you can see a basic code has been given. Here you can see how the REST controller, how the request mapping, and all the syntax has been given, uh, which is very helpful for the making of it. Now, receiving a request isn't enough. For example, we order we order something from the waiter. Now what happens at behind? Let's see this. A service layer has been functional for this. From the controller layer we have a service layer, and in the particular service layer it contains the business logic and transaction management, everything which handles in this service layer. And then it goes to the repository layer and then to the database, and this particular whole cycle repeats itself until the final outcome to the client has been retrieved. Now, where does the data come from? A user makes a request, show me all the students. The application needs to find that information, right? Then this data comes from a database, which has been directly linked to the repository layer. Repository layer, it performs the CRUD operations and data access, which is responsible for the service layer to provide it to the controller layer and to the client. And here is the architecture you can see. How does the application connect? For example, how does the Java represent this particular data? It is in the uh, entity format. For example, as we have studied in the previous classes about the ER diagram. In ER diagram, you can see all the tables are been mentioned, the Java entities are been mentioned in format of Java and the ER table. Here you can refer. Moving on forward, as we have seen all this in a particular manner, let's see how they are grouped together to work in a very sequential manner. A complete architecture here you can see. Client, the Spring Boot application. The Spring Boot application has four layers, which is the controller layer, the service layer, the repository layer, and the entity layer with embedded servers like Tomcat, Jetty, and Undertow. What if two application needs to talk? For example, imagine a mobile app, the Spring Boot server, and the database. How does the mobile app then communicates with the Spring Boot application? Let's see. REST API. REST APIs are basically API endpoint which controls the service layer and the Spring Boot main embedded servers. Here you can see an example has been given. For example, imagine a student management system. A user could say, show me the students, add a new student. Now these are been done through the HTTP methods. For example, a method like get, post, put, and delete, which is similar to the CRUD operations that we use in like the basic like MySQL and MongoDB. Here you can see the basic syntax has been given for each of the operation. Moving on forward, the API example. API example are just basically same, like similar to the HTTP method. Here you can see get, post, put, and the delete option has been given with their respective syntaxes with an example. You can verify it from here. So this was the whole PPT about Spring Boot, and thank you everyone.